Alright, so the next part is data visualization, right? So this is the other form of EDA, which is very, very important. So I want to first of all start with graphs for quantitative variables. I want to start with histogram, right? Histogram is one way to graphically represent the distribution of your data using bars of different height, right? So this hist function can be used to get our histogram plot, right? So in this function, I just want to make use of separator length, right? I can basically use dat final dot dat, right? And just use the dollar sign to pick. But because I've already attached this, I can basically just get rid of this, right? I can get rid of all of this because I've already attached the final dot. So once I write separator length, it picks that variable from final dot dat for me, right? So I want to plot histograms, get a histogram plot of separator length, the probability. I want to get a frequency instead of probability density, and I want to give a color of blue. So let's run this. So once we run this, let's see what appears. So in our plot window, we see the histogram of sepal length, right? Looking at this, it will be very difficult to describe this, but as we explore more, we can draw a conclusion to this. So let's explore more. So this is just for one of the variables. Maybe I want to get histogram plot for all the other quantitative variables. So I'm going to use another function. So first of all, let me clear the graphics, right? And use this to basically do that. So this function is basically going to give me 4 columns in my plot window. So basically for one row in this window plot, I need 4 columns, right? That's the basic meaning of this function. Then this is basically going to say that I'm going to use the for loop. So for index I in 1 to 4, I want to create histograms for each of the variables in my final dot. So I'm going to use hist to get a histogram plot. Then my data set comes, which is the final dot. I want for all rows, I'm using the index I, right? Because I want to pick the columns or the variables. And the main, I want to basically give a title. So I want the names for that variables that I am making use of. And let's see what continues. Now I want to get the probability densities to be true instead of making it false. I don't want the frequency this time. I want to get a density, right? I want a density plot, right? So let's quickly run this. So once we run this, what do we see? So here we go. So we get our density, right, for the histogram for each of the variables. So this is separator length, separator width, petal length, petal width. And from in here, we can see that separator width seems to be approximately normally distributed. Petal width, petal length, petal width seems to deviate from normality, right? With separator length, it is somehow very difficult to even describe. So let's explore more. So now I want to use the Lattice library. This is one of the library that has more advanced features which can improve in data visualization. Very, very important if you want to do data visualization. You need this package as well. So let me quickly run this. Once I run this, I want to clear my graphics. So I still want to set my window, my graphics window, to have 4 columns, right? I want my window to have 4 columns, so just one row, 4 columns. And I want to say for index, using the for loop for index I in 1 to 4, I want to plot a density. I want to get a density plot now. So from the Lattice library, I can get a density plot instead of histogram plot. So in this plot, I want the density for my final data, and I want for all the rows, I want to pick the columns. The main is the names. I want the names of my variables to appear. Right, so let's see the continuation, the names of my variables to appear. Right, so let's quickly run this. Alright, so once we run this, here we go, we have the density plots. Right, so we can see that of sepal.length, sepal.width, peta.length, and peta.width. Let's continue with other data visualization. So now what do we want to do? We want to create a box plot for each of the variables. So let me first of all clear this graphics. Right, so once we run this, we clear it. So I still want to divide my window, my plot window into 4 columns, just one row, 4 columns. And now I want to get a box plot for each of the variables. So for index I in 1 to 4, box plot, my final that, right? And I want to get a column. So um, the main is basically going to give the title, right, for each of the box plot. So I want the names for my variables to appear. So let's quickly run this. So here we go. So we have the box plot, right, and we can see that now you see with the data exploration, we can see that sepal.width seems to have some extreme values. Having extreme values doesn't mean it is an outlier. You have to be very careful when you're dealing with an outlier. It is very, very important. An outlier is any observation that is not consistent with the rest of the data values, right? So the fact that they are extreme values, that does not mean that they are outliers. You have to, with outliers, you have to be very careful when you're dealing with outliers. It is something that's very subjective, and you have to be very careful when you are dealing with outliers. For instance, let me use this as a scenario. Let's assume these are the scores of some student in a particular from a particular test, right? And let's assume this is in percentage, so the total is supposed to be 100%, right? Let's assume one of the observation or one of the students had a mark of, let's say, 100. Let me type it, 123. This is an extreme value, and it is an outlier, right? Because if you look at percentage, it's supposed to be 100%. So if someone is getting more than 100%, then it means that this is an extreme value and it has to be omitted. So when you are deleting a value like this from your data set, it is reasonable. Now let's take another example. Let's say now one of the students had a mark of 5. You can see from here that the center for this distribution for the scores will be around 60 to 70, right? That's going to be the center of these scores. But here we go, we have someone getting 5, which is an extreme value, right? But this is not going to be an outlier because it is still within 100%. 5% is still within the percentage category. So the fact that you have an extreme value does not necessarily mean that it's an outlier. So anytime you're dealing with outliers, you have to be very careful, right? So let's continue. So with the box plot, we have seen some extreme values, right? So you have to be very careful when you are trying to treat them as outliers. Let's continue with the data visualization. So what do we want to do? Yep. So now I want to use another more advanced um, features which can improve the quality and aesthetics of our graphics by using a library known as Ggplot. This is very useful for data visualization. So let me load this library. Alright, so let me clear this. So I want to do most of the plot that I've already done with Ggplot. So we're going to start with histogram, right? So first of all, I want to do a histogram plot. So I want to assign my plot to P1, and with a Ggplot, the first argument is basically your data frame or your data set, right? And the aesthetic mapping, the AES is basically your sorry, is basically your aesthetic mapping, right? Which basically describe how the variables in the data will be mapped to visual properties like your histogram plot or your density plot, right? So in here we want to pick this where you basically assign your variable. So I want your x coordinate to be your separate length, right? Because you just want to get a histogram plot for this variable. So histogram plot. So what do we do? So we have this function to help us get a histogram plot. That's a geom histogram underscore histogram, where the bins being 30, right? The bins are basically it represents a single. The bin basically represents a single, or it represents a range of values, right? So we want it to be 30 by default. You can basically change this, but we want to maintain the default to be 30. I want to give a color to this to be green. I want to fill it with white. I want to fill our histogram plot with to be white. So let's quickly run this and see how it will look like. Oh, I have not run this, so let's go back and run this. Yep. Okay, so now we can run this. Okay, so here we go. So it will show very soon. Yep, so here we go. So we have filled it with white. That's why you see the bins being filled with white, right? And we can also see the count. So we can add more things to it. So I'm going to add a plus and say press enter and say I want to label this. So I'm going to use the labs LABS, right? And say I want my s coordinate to be, I don't want it to be sepal.length. So I want to use sepal length, right? And let's say my y coordinate, right? I want it to be frequency. So let me use frequency. And I want to give a title as well. So title, right? To be histogram of sepal length, right? So let's rerun this. All right, so here we go. So yep. All right, so let's continue. Now I want to get a density plot using the Ggplot. So with the same plot one, right? Ggplot. I want to add histogram. Sorry, I want to add a density plot to the histogram that I have here. So there's a function to help us do that. Right. So with my histogram, right, with a that's a separate length, I want to add a density plot to it. So with a static mapping, I want my y coordinate to have the density, and my bins is still going to be 30 for that. The color is still going to be green. I want to fill it with white, right? That's my geom histogram, right? You see that the first one, if you scroll up, I set the x to be separate length. So this is basically going to add a density plot to the histogram that I already have for the separate length, right? And I'm going to fill it with white. Then I'm adding another argument to it, or another function. That's a geom density with an area of, let's say, 20%, right? And I want to fill that density plot with orange. Then I want to give a title to what I'm trying to do. So histogram of density plot of the separate length. So let's run this. Alright, so here we go. So you see now with my density histogram plot that I've now added a density plot to it, and you can see that this is seems to be plasticartic, right? That's how the distribution of the data looks like. Alright, so let's proceed. The next thing that I want to look at is now we want to get a histogram plot by the levels of the species. You know that if you look at your data set, for each of the variables we have different species. We have sepal, we have setosa, we have three levels of the species. We have setosa, we have versicolor, and we also have Virginica, sorry for my voice for today. I think I'm having some throat problem. So for each of the variables, we have three different species. So we want to get a histogram plot by adding this species to it, right? So I want to now give it a new name, right? So the first, let me go back. The first one is basically my Ggplot. Find out that I want my x coordinate to be separate length as well, right? And I want to color it by species, right? So I want to see the species for each of these um, variable or the values that I was having, right? For each of the data points, I want to see which one of them is setosa, which one of them is vesicolor, which one of them is virginica, right? So that's basically what we are trying to do. And so with a plot, we are still going to use geom histogram, being static, fill it with white, and want to add a title to it, right? So let's run this, right? So let's run this. All right. So it's just taking some time to show. So I think we can proceed once it shows. We can describe it, right? But most of the time, you have to also know how to um, interpret this kind of graphics. It's not just using the software to get the result, but also interpreting it is very, very important, right? So I don't know why it's taking time to show. Um, Let me rerun it again. So I think the first part, the second part, yep. So let me rerun it again. Okay, so it seems we're having some challenges. Let me run the first one. Oh, okay, so here we go. I think it's not showing it. Let me rerun it. Right, and run this. Alright, so here we go. So we have so for each of the bins we can see those values which are setosa, which are vesical, and which are virginica, right? In fact, there are more that you can add to Ggplot, right? So I think if you can get some books on Ggplot too, there are more that yeah, I think you can add, right? This tutorial is very short. We can't cover everything on Ggplot, right? So let's proceed. So the next thing is how to get a box plot using Ggplot. So I'm going to get this first argument. So I want to get my Ggplot. So my final dot and my x coordinate from the static mapping is going to be separate length. My y coordinate is going to be species, right? And I want to color this by species so that it can give me the legend as we have seen it here. So once then I want to plot this using the geom box plot, which is going to basically um, give me a box plot for the separate dot length. So let's quickly run this. So here we go. So we see now the box plot for only separate dot length, right? And we can see for Virginica it has some of the values seems to have extreme values, right? And so that is with the box plots using Ggplot. We can also flip this. Maybe you don't want to see the box plot in a horizontal form. We want to see in a vertical form, so we can use this function, the code flip. Right. So let me rerun this. So this is basically going to change the position of the box plot from a horizontal format to a vertical format, right? So it's taking some time to show. There's a warning message here. Yep. Um, okay, let's run this. Yep. And let's run this. I don't know. Yep. So I don't know why it was delaying. So here we go. So it has now changed it from that horizontal format. Now you can see it in different formats, right? So as I've said, there are more to Ggplot. So if you can get a book to maybe read on, it will help you to know how to add more um, functions to this to make it work nicer. So let's proceed. Now I want to look at correlation plot. So with correlation plot, you can just make use of the plot function and just introduce our final data. That's our data frame. We want to pick the first four columns, which are quantitative, right? And want to give a color of a rainbow color. Want our heading. The main is basically going to give you a heading. So we want scatter plot of the array data. So let's quickly run this. So here we go. We have scatter plot of the iris data. So we can see in here that there seems to be a strong correlation between a strong positive correlation between sepal.length and petal.width. The same applies between sepal.length and petal.width. You can also see some positive correlation between petal.length and petal.width. So another way to basically view your correlation plot is by making use of a library known as the Ggplot, right? The Ggplot function basically creates a graph of correlation metrics, coloring the regions by the level of correlation. So first of all, we have to load this library, but if you have not installed this, you have to install it by using the install.packages or go to packages and install, right? So because I've already installed this, I want to run this, right? So once we load the library, we have to first of all get our correlation from the quantitative variables that we have, right? So I want to get a correlation. So this is the correlation data. So I want to get a correlation from my data set. That's the final data, the first four columns. So let me run this. So this gives me a correlation, right? So if you want to check that, you can just run only this part to see the correlation, right? So once we have this, let me clear the graphics. Alright, so now using the Ggplot function, can get my correlation, right? And it makes use of the correlation data. Then the method is going to be circle, right? That's going to show us the correlation between the variables. So let me run this. So here we go, right? Let me zoom it so that we can see it in a more clearer way. So I want to view it or zoom it so that it becomes more clearer to view. So it's taking some time to show, I don't know why. Alright, so we can see that once it's getting to 1, we see that the color is very deep, right, like dark blue, right, and you can see it those around 60 to 80% is light blue. So we can see between sepal dot length and petal dot length, right, and we can see that once it's getting to 0, we see it to be in this form of color, right. So basically, if you want to see the correlation, the strength of the correlation, you can change the method to number. So once I change it to number and rerun this, let's see what happens. So we can see that 1 is very highly correlated. So you can see that there's a strong correlation between sepal dot length. There's a strong positive correlation between sepal dot length and petal dot length. Sepal dot length and petal dot width. The same applies to, there's a strong correlation between petal dot length and petal dot width, right? There seems to be a strong positive correlation. So for instance, if you want to do regression, this can even help you to know which one to regress, right? So it's very important we pay close attention to data visualization. So next is to basically use Ggplot to basically get our scatter plot. So I want to assign my plot to SP, right? So this will help us to get a scatter plot. So I'm using my final dot, the static mapping, my x coordinate. I want to use sepal dot length, my y coordinate. I want to make use of the variable petal dot width, and I want to basically plot this using geom point, which is going to give me a scatter plot between these two variables. So let's quickly run this. Let me run this. So it's taking some time. I don't know if I run the two together, it always takes some time to show. But if I run it individually, so let me run the first one. Yep. And let me run the second one now. Okay, so now we see the correlation, sorry, the scatter plot between these two variables. So this is how you can use Ggplot, right, in a univariate case, right? So the next thing is to look at graphs for qualitative variables. So in here, let me first of all clear the graphics. Graphs for qualitative variables, the most commonly one is the bar plot. So I want to create a bar plot for the categorical variable in our data set, which is a species. So first of all, I want to get a frequency distribution for my species variable. So I'm using the table function, right? And I'm assigning everything to tab. So once I run this, let's see. So the tab, once you run all the tab, you have a frequency distribution for your species variable, right? So once I have this, I can get my bar plot. So the bar plot function, the first one is my tab, right? That's the frequency table. Then the main, that's the title that I want to give is bar plot. So let me add bar plot of species. Right. So my y-lib is to basically name my y coordinate to be frequency. My x-lib is basically define my the title for my s coordinate to be species. I want to give a color for this bar plot, and I want it to be orange. So let's run this. Alright, so here we go. Alright, so we can also do this using Ggplot. So using Ggplot, first of all, to get a data frame, right? So in this data frame, I have my first variable to be species. So I have the name Setosa, Vesica, and Virginica, right? And the other variable is going to be the frequency. So I have 49, 50, and 49. So once I run this, I have my data frame. So with this, I can use my Ggplot to get my bar plot or the bar graph. So the first function is basically Ggplot, and the first argument is where you place your data frame. Then with the static mappings, I want my X to be the species, right? The X coordinate to take the species and the Y coordinate to pick the frequency, right? Then I want to color it by species so that I can get my legend. And I want to basically plot this using geom_bar. That's going to help me get my bar plot, and I want to fill this with green. So let me run this first. Right, let me run this. Yep, and now let me run this. So here we go. So this is how to use Ggplot to get your bar graph, right? The other commonly used graph for qualitative variable is the pie chart, right? So I want to create a pie chart. So just use the function pi, right? And we make use of the frequency distribution table as a tab. So once we run this, we get a pie graph or a pie chart for our categorical variable, right? So I think this will bring us to the end of EDA in R, how to do exploratory data analysis in R. Please, if you find value in this video, don't forget to subscribe if you have not, and also turn on the notification bell to get more updates anytime I post on this channel. Thank you for watching.